Hello everyone and welcome to a new video. The topic we are going to learn today is the properties of integers. So what are the properties we are going to learn today? The closure property, the commutative property, associative property and the distributive property. Now before I can proceed with the video, I would request you to kindly subscribe to my YouTube channel if not done yet. Please do not forget to press the bell icon. Besides that, you're going to find a few links. Make sure you join the Telegram group because that's the place where you're going to get all the updates. So let's move ahead and start with learning the properties. But before that, a quick recap and introduction to the various categories of numbers. So natural numbers over here are all counting numbers. It starts from 1, 2, 3, etc. They do not include negative numbers and 0. What are whole numbers? Whole numbers are a set of all natural numbers including a 0. What are integers? Integers are a set of all whole numbers but they have negative numbers also. What are rational numbers? Rational numbers are all integers which can be expressed as a fraction a upon b where b is not equal to 0. So now that we have done a recap of this, let's move ahead quickly and understand the various properties. First one being the closure property. So what does the closure property state? The closure property states that when you perform an operation such as addition, subtraction or multiplication on any two integers, the result will also be an integer. So let's check it out. So for the addition, we have taken two digits over here, minus 2 plus 3, which is equals to 1. So since this is also an integer, we call this property closed for addition. For subtraction, we have taken 3 and minus 5. The result is negative 2, which is an integer, and hence we call this closed for subtraction. So if you take multiplication, minus 2 into 3, it's negative 6. Again, it is a integer, so you call this closed for multiplication. Now in case of division, if you take minus 6 divided by 12, you get negative 1 upon 2, which is a rational number and not an integer, hence we call it not closed for division. Next we move on to the commutative property for integers. So what does this property state? The commutative property states that the order in which you add or multiply two integers does not change the result. What this means? Let's say we have an addition a plus b is equals to b plus a. So when we take two integers, negative 2 plus 3 is equals to 3 plus minus 2. So minus 2 and plus 3 is 1 and 3 plus minus 2 is 1. So when you interchange this position for addition, the result does not change, hence you call it true for commutative property, true for addition. Now let's check out for subtraction. A minus b is b minus a. So 3 minus 5 on the left hand side and reversed it, 5 minus 3. So minus 5 and plus 3 you get a negative 2 and 5 minus 3 you get a positive 2. So you can see both the sides are not equal, LHS and RHS are not equal. So you're going to say that the commutative property is not true for subtraction for integers. Let's take on multiplication. A into b is equals to b into a. So negative 2 into 3 and 3 into negative 2, we have interchanged the position. So 3 2 is 6 is negative 6, 3 into minus 2 is also negative 6. Both the LHS and the right hand side is the same, so hence you call this true for multiplication. Finally, we check out the division. A divided by b is equals to b divided by a. So let's take example, minus 6 divided by 3 and 3 divided by minus 6. So this on the LHS will have minus 2 and on the RHS will have negative 1 upon 2. So you see both these are not equal, hence this property is not true for division. Next we move on to the associative property for integers. What does the associative property for integers state? It states that the way in which the numbers are grouped in addition or multiplication does not change their sum or the product. So let's check out an example. So we have three numbers over here, a, b and c. A, b and c over here. What you can see over here, the grouping is done separately. So b plus c and a plus b. Let's check out an example. So let's say we have these two these three integers minus 2, 3 and 4. Here we have changed the order. Now what we have done is we have grouped b and c. So 3 and 4 we have grouped and a and b over here. Now let's try to solve the LHS in the right hand side. So first using BODMAS, here 3 plus 4 is 7 and negative 2 plus 3 is positive 1. So if you don't know how to use BODMAS, or if you are in a country where you use PEMDAS, I have a separate video, you can go out and check the same. So when you solve this, you get negative 2 plus 7 and on the RHS 1 plus 4. So this is 5 on the LHS, 5 on the RHS, hence you would call this associative property closed for addition for integers. Next is the subtraction. A minus B minus C is equals to A minus B minus C. So let's take an example over here. 3 negative 2 and negative 2 over here. So you interchange over here the positions, I mean the grouping over here. So here you're going to group 5 and 2, and here you're going to group 3 and 5. So again, solving the bracket plus 5 minus 2 is 3. So you have 3 minus 3 of the LHS, and the RHS you have 3 minus 5, which is negative 2 minus negative 2. So if you solve this on the LHS, you get 0. On the RHS, you get negative 4. So it's not true. For multiplication, A into B into C is equals to A into B plus C. So again, this number you see, you group 3 and 4, you group 2 and 3. So using BODMAS, you say we sort this out first. So you have minus 2 into 12, and here you have minus 6. So 2 12 are 24, 6 4 are 24. You can see both these sides are matching. Hence, this is true for multiplication. Finally, you have division. A divided by B divided by C is equals to A divided by B divided by C. So let's solve it. So you have negative 6 divided by 2 divided by 3. And on the RHS, you have 6 divided by 2 divided by 3. Solving the bracket 2 upon 3. Over here, you can see a division. So you're going to inverse and multiply. That's how I've done instead of making it too many steps. So minus 6 multiply by 3 upon 2. So this is inverse and multiplied. And on the RHS, you have 6 divided by 2 is 3, negative 3 divided by 3. So 2 and 6 will cancel. You'll have 3 3s are 9, negative 9. And the RHS, negative 3 divided by 3 will be negative 1. So both your LHS and RHS are not matching. Hence, this property is not true. It does not hold good associative property for division of integers. The last property of integers what we're going to discuss is the distributive property. So what does the distributive property state? It states that multiplication distributes over addition or subtraction. So let's check out an example of multiplication over addition first. So you can see A into B plus C is equals to A into B plus A into C. What does this mean? You multiply A into B first, then the addition, and A into C. So this multiplication is distributing over addition. Let's do an example. You have minus 2 into 3 plus 4 is equals to, it will be minus 2 into 3, then you have the addition sign in between, and you have minus 2 into 4. So when you solve over here, you need to solve the brackets first, because we always solve the BODMAS. So people who are using from other countries PEMDAS, you can, or guys from India, you can always check out my video, BODMAS versus PEMDAS, and you can check out how to do it step by step. Now first let's check out the bracket. So it's minus 2 into 7, and here on the RHS it's going to be to the 6, negative 6 and negative 8. So when you solve this, you have got 7 2s are 14 over here on the LHS, and on the RHS also minus 6 plus minus 8 is 14. Since the LHS and the RHS are the same, you will call that is distributive property, that multiplication distributes over addition. Then you check out the same thing over subtraction. Here A into B minus C is equals to A into B minus A into C. What does this mean? It means that you multiply A into B, and the negative sign will come over here, and you'll have A into C. So multiplication basically distributes over subtraction. So here an example, minus 2 into 5 minus 3 is minus 2 into 5 minus 2 into 3. So how is it? You have first negative 2 multiplied by 5, which is over here. Then you have the negative sign over here, and then you have negative 2 multiplied by 3. So you have negative 2 into negative 5 minus 3 is 2, it's solving the brackets, and negative 2 into 5 is negative 10. So 2 minus 2 is 4, and 10 minus 6 is 4. LHS and RHS is both the same, hence we call it distributive over subtraction. So this is a tabular table. You can see over here that the addition and the multiplication operations are all closed, or they all follow the properties: closure, commutative, associative, and distributive, and the rest of the things don't. So I hope that you like this particular video. Do let me know your feedback in the comment section, and do like this video, do share it across. Until the next video, take care and be safe.